Welcome! In this brief video, we will explore the aptomi service model. Aptomi sits on top of the microservices infrastructure and relies on the package and configuration mechanism provided within the Kubernetes ecosystem, such as Helm, or it can work directly with YAML files. Aptomi takes the service intent, which is the code, service definition, and rules, and all of the definitions of the cross-service or application team dependencies. In addition, aptomi takes in ops, governance, and security rules, along with service ownership information to adaptively control the services, with performance, state, and other operational data influencing the enforcement. Aptomi deploys, operates, scales, and updates services for you and runs them on multiple clusters and clouds. Aptomi helps developers focus on what matters, defining and running their services, as opposed to dealing with individual containers and disjoint configs. Aptomi simplifies the definition of an application service and its delivery and control. A developer specifies a self-contained autonomous service with all service, lifecycle, and resource controls defined. Once the service is defined, it is shared for consumption with other users, teams, or services. Sharing is done in a way that the service can be consumed and reused without understanding the inner workings of the service. Consumers can focus on their deliverables and their services without having to worry about how the service they rely on works. This greatly simplifies the interactions between teams and saves a lot of time. Once a service is up and running, aptomi allows you to observe and control services in a highly contextualized way. You always know what dependencies exist, why those dependencies have been instantiated, where things are running, on whose behalf they were instantiated, and who's consuming them. Aptomi can also answer questions around what would happen if you were to change some of the rules and configurations. Additionally, aptomi allows ops, governance, and security controls done in a way that does not disturb the developer or the service owner. Now we'll look at the aptomi service model. A service definition is a collection of multiple components such as code, parameters, and rules that affect the life cycle of the service. The service is advertised through what we call a contract. Within a contract, there are multiple clauses. A clause might dictate how the context of the service is allocated to specific types of consumers or groups of consumers. A clause could also dictate whether the service is a private or a shared instance, and in the case of a shared instance, how it will be shared. For example, if we are to allocate multiple shared instances per sets of consumers or otherwise. In this example, we have production shared for our production consumers. We've also created production private for important consumers, giving them dedicated instances, and stage, which might have different code or scaling characteristics and different placement parameters. We also have dev test, which points to a completely different piece of code. For example, we are pointing to a mock or a fake piece of code that simulates a certain function. Now, as a consumer, you don't know which one you're going to get. For example, let's say I have a service that offers an SQL database, and for very important users, you're providing MySQL. For other users, I might offer a lesser database that doesn't require any licensing. Services and components can depend on other services. As a service owner, you know which things your service depends on. Your consumers consume your service by relying on the contract. This allows you to obfuscate the inner workings of the service from the consumers, so you don't need to understand what's going on operationally within the service. You're only dealing with the contract. This model provides a very nice self-contained way of defining services and how a service operates. It provides very tight ownership boundaries since this model is controlled by the owner of the service. Out of all of these pieces, aptomi stitches together a complete application graph. Each node in the application graph is essentially crowdsourced by the respective service owners. The big picture is stitched together from all nodes and services. Aptomi can be controlled from an IT perspective from service and infrastructure policies and IT service policies. For example, you may dictate a particular service may run with redundancy in production, but no redundancy in the staging environment. You might also confine certain labels to a particular cluster, such as a service labeled test must only run in the US East cluster. You could also use a label to move the service to a new cluster. Labels could also be used to control security and compliance. For example, you could constrain production to only run certified container images. Or you could ensure untrusted workloads are quarantined from sensitive workloads. Or you apply constraints on things you pay licensing fees for. For example, limiting MongoDB enterprise licenses to 100 to control costs. For dev test services, you might mandate dev teams cannot deploy to production, and further add each dev gets their own instance of memcached in stage. You can also optimize your utilization by specifying a rule to terminate test instances overnight in a particular cluster. Aptomi's rules provide powerful security, governance, and operational control and enforcement. In summary, Aptomi simplifies rollout and operation of container-based applications and services on Kubernetes and introduces a service-centric abstraction focused on understanding the relationships between application components, rather than today's infrastructure-centric approach. Thank you for listening. Please visit us and join the conversation in one of these channels. Thank you.